Hi, my name is Anush Dcosta and I'm a third year computer systems engineering student at Middlesex University, Dubai. Here, I will be presenting my project Cogni-Jarvis, an AI-powered virtual assistant that is designed to simplify task management and improve productivity, especially for students. In this presentation, I will walk you through the motivation behind Cogni-Jarvis, the system architecture and the implementation phase, explaining how I integrated edge hardware with complex AI workflows, before concluding with a video demo and a future roadmap. For neurodivergent individuals, traditional productivity tools often suffer from the ADHD design paradox, where high choice density and visual noise actually trigger task paralysis. Cogni-Jarvis addresses this by moving away from the distraction of the mobile screens. By built on the Raspberry Pi 5, it acts as a physical scaffold, providing a single task HUD to promote functional independence and combat time blindness without the usual digital distractions. To ensure the system was effective, I defined strict functional and non-functional requirements. Functionally, the device must handle localized voice processing for privacy and provide focus nudges. On the technical side, I targeted a response latency of approximately 5 seconds and prioritized offline resilience. Most importantly, the UI UX is built on a human-centered design to prevent the very choice overload we are trying to solve. Now, let's look at the system architecture. The architecture is made up of 4 stages, beginning with stage 1, which is the local capture, in which we use an I2S MEMS microphone for high fidelity audio. Stage 2 is the neural processing, wherein the transcription is done using an OpenAI's Whisper with the faster Whisper library. This is optimized for the edge. Stage 3 is the cognitive pipeline. This is the brain where an innate agentic workflow interacts with local LLMs to extract intent and provide answers. Stage 4 is a multimodal scaffold wherein the output is pushed to a single task SUD as well as played on the speakers using text to speech. It is also synced by Bluetooth to the mobile phone for schedule monitoring. Now, the core of the project is the handshake between the hardware and the AI. For the hardware integration, the Raspberry Pi 5 serves as a central hub. To eliminate analog noise, I have made use of the WM8960 sound card. The visual feedback is delivered via a 5-inch display that generates flow state progress pulses. The voice processing is done using a 3-stage voice trigger system with the use of various different models mentioned here. I've also done the orchestration using NA10 to manage complex logic. This allows the system to take raw voice dumps and extract structured data. The mobile handshake is done using Bluetooth for secure low power pairing and also HTTP to allow for real-time asynchronous communication between the NA10 backend and the user's phone. Cogni-Jarvis isn't just for the students. It's a dual mode ecosystem. The phone app includes a parent mode coaching hub. Instead of just showing raw data, I use specialized prompt engineering to turn the AI into a parent coach. It provides empathetic, actionable tips based on the student's progress. We also have a vocal thought dumps where raw recordings are automatically reformatted into structured schedules. Beyond its specialized ADHD support, Cogni-Jarvis handles standard virtual assistant tasks such as music playing, reminder setting, as well as complex question answering, making it a versatile tool for daily life. Looking ahead, my goal is 100% edge autonomy, moving the entire cognitive engine onto a more powerful microprocessor to remove the need for a secondary laptop host. I also plan on integrating distraction detection using a camera to sense when the user is drifted away from their desk, as well as refining the scheduler logic to prevent user burnout. Now, I will be showing a video demo of my project.
Hi, I'm Anush, and this is the final look of my project Cogni-Jarvis, an AI-powered virtual assistant designed especially for students with ADHD or autism. So now, let me demonstrate the various different features of this project. Once the system is powered, the virtual assistant enters into standby mode. In order to enter the listening state, the user will use the wake word Jarvis. The system makes use of a human in the loop approach by ensuring that the user is aware of the entire process by using HUD updates.
Good afternoon, Anush. Life is not about waiting for the storm to pass, it's about learning to dance in the rain.
Jarvis. The user can ask questions, request for music, inform the virtual assistant about any of the tasks, or even casually communicate. Jarvis. What is the name of the first US president?
The first US president was George Washington.
Jarvis, play some music.
What song do you want to listen to?
Never gonna give you up.
Jarvis. I need to put off the oven in 10 minutes.
Reminder set.
Jarvis. I have to complete a report on the different types of solder used in SMD components. I have to complete the report in 2 weeks.
The database was updated successfully.
Jarvis, good morning.
Good morning to you too. Smiling face with smiling eyes.
In order to connect the companion app to the machine, the user has to first double tap on the button on the side of the machine. This QR code will then be scanned by using the QR code scanner on the app. Now I'm going to show the app. The app requests for various different permissions. After this, we are shown the main homepage and the guide to set up the device. On scanning the QR code, the phone is then connected to the machine. Clicking on the pie shows various different metrics. We can also click on the settings bar on the bottom. This shows us the various different settings that have been set for the student. When we click on the speak to agent button, we are given two options. The Cogni-Jarvis chat is the same chat that is used on the virtual assistant. The parent mode chat, on the other hand, allows the parent to monitor the various different features of the child. This includes monitoring the child progress. The next one, getting any parental advice. This allows the assistant to give a step-by-step process on how to perform the action. As you can hear, it also does a text-to-speech feature where it speaks out whatever is being shown here.
Let's work together to create a supportive environment.
The chat also has its own speech entry. What is the name of the first US president?
The first US president was George Washington.
Along with this, the parent can also view the schedule of the student. This concludes the functional walkthrough of my final project, Cogni-Jarvis, which featured initialization, backward activation, and scheduling, as well as various other features between the app and the machine. Thank you.
In conclusion, Cogni-Jarvis successfully bridges the executive function gap by optimizing AI latency and implementing a single task HUD. We've created a solution that solves the ADHD design paradox. While current hardware limits require a hybrid edge approach, the foundation is set for a fully independent physical scaffold for neurodivergent individuals. Thank you for your time.